Hello all, welcome back. Today we are going to do an introduction to Azure Storage. Azure Storage is a massively scalable cloud storage platform which is helpful in designing large-scale internet-based applications. It is designed to be able to store huge amounts of petabytes of data and also gives geo-redundancy along with great performance. So based on the data classification and other operational needs, Azure Storage offers a massively scalable object store for being able to store data objects, disk storage for Azure Virtual Machines, the VHDs, file system services for the cloud, which is the Azure Cloud File Share, messaging store for reliable messaging, and as well as NoSQL store. The key characteristics of Azure Storage are, it is durable and highly available. Durable, as the name suggests, it means that ability to withstand failures. Through redundancy, Azure Storage ensures data safety in event of transient hardware failures, data center level failures, zone failures, or even regional failures, so on. Consistency. The storage service is designed to support a strong consistency model. That means that any update to the data is directly reflected to all the redundant copies wherever the data is distributed. The other model could be an eventual consistency model, which means that the data is asynchronously copied versus in the consistent model, the data is synchronously copied. The data is highly secure. The data is encrypted at rest, in transit, and even fine-tuned control can be given as to who can access the data and what amount of authority can he have on the data. It is massively scalable because it can meet the data storage and performance needs required for today's applications. It is a managed service, that is because the underlying hardware updates or even handling critical issues on these infrastructure is handled directly by the Microsoft team. Globally accessible. It is accessible anywhere in the world over HTTP and HTTPS in the endpoints, and you can access it in the variety of ways through PowerShell, command line interface, portal, tools like Storage Explorer, and even client libraries in variety of languages like .NET, Java, Ruby. And the list is updating even as we are making this video. So these are few of the characteristics. Let's move ahead. There are a lot of storage services, but we are focusing on the core storage services. The first one is Azure Blobs, which is a massively scalable object store for storing text and binary data. It even includes support for big data analytics through Data Lake Storage Generation 2. Azure Files, it is a managed file share for cloud or on-premise deployments. Azure Queues, it's a messaging store for reliable messaging between application components. Azure Tables, it's a NoSQL store for schemaless storage of structured or semi-structured data to be precise. And disks, it is a block-level storage volumes for Azure VMs, the VHDs. Let us understand some of the application of these core storage services. The first one is Blob Storage. Blob Storage we use for storing photos, media files, log files, text files, etc. all kinds of files. And when you're building applications with audio and video streaming, even for storing data for backup and restorations, disaster recovery and archival, Blob Storage finds its major use. File storage. This offers fully managed cloud file shares. You can access the files from anywhere via the industry standard SMB protocol. And whenever you're having a farm where multiple virtual machines need to install common tools and utilities, you can store this data required in a file share and all of your VMs can access the file share, just like how you access the on-premise network file share whenever you want to install common utilities. Queue storage. The Azure Queue service is used for storing and retrieving messages up to 64 KB in size. They can contain millions of messages. Queues are generally used to store lists of messages to be processed asynchronously. When you want to decouple your application components and use asynchronous messaging to communicate between them, queues are an effective mechanism. To understand this, consider this scenario very quickly, that you have an application where users can click a button and a PDF file generates in the backend. Now the user can deviate to any parts of the portal instead of waiting for the PDF generation to complete. In such cases, you can create two different application components. One is the web itself, other is a web job or a backend processing mechanism. So from your website, you basically push a queue message saying that this particular employee ID wants the PDF to be generated. And then you have a background application which runs picking up this message, dequeuing it to be precise, and processes it. So this kind of decoupling is one of the major advantages of queue storage. Table storage. To store flexible data sets like user data for web applications, even product catalog data for e-commerce applications, table storage is an effective mechanism. This is now part of Cosmos DB, and storing data sets that do not require complex joins or relationships, and if they can be denormalized for faster access, and especially for semi-structured data or NoSQL kind of data, table storage is the way to go. Disk storage or managed disk. These are like physical disks in an on-premise server but basically virtualized. With managed disk, all you have to do is specify the size of the disk, type of the disk, and provision the disk. The rest of the activities in the backend, Azure will do it for you. It will create underlying page blobs which are optimized for random writes and random reads, and it also creates the blob containers and thus provides an abstraction over all of this. So very quickly, the recap from our very first videos, that when you create a virtual machine, you have an option to do a disk option. Here, when you're provisioning a data disk, you can either use a managed disk, yes or no. If you say yes, then Azure will do the magic for you. And if you say no, then you'll have to go ahead and create a storage account and all the underlying things and manage it yourself. And thus, when you say no, it is called an unmanaged disk. The next important feature of Azure storage is its redundancy. Azure offers two kinds of redundancies, redundancy in primary region and redundancy in secondary region. In the first category, you have LRS and ZRS. Locally redundant storage copies your data synchronously 3 times within the single physical location or the data center in the primary region. This is similar to like a availability set, which means that your data is copied 3 times in different racks or on different fault domains. Zone redundant storage copies your data synchronously across 3 Azure availability zones in the primary region. This is similar to availability zone because every region has 3 availability zones, so your data is copied synchronously across 3 different zones. In catastrophic scenarios where your entire region is down, then neither of them ensure the durability of data. Hence, the second category, which is further more durable, which is redundancy in secondary region. They are GRS and GZRS. In geo-redundant storage, it copies your data synchronously 3 times within the single physical location using LRS. And then it copies your data asynchronously to a single physical location in a secondary region, which probably is the region pair, which is predefined by Azure. And geo-zone redundant storage also copies your data synchronously across 3 availability zones using ZRS, and then it copies your data asynchronously to a single physical location in the secondary region. There are 2 other options of redundancies, which is read-access GRS and read-access GZRS. Can you guess what happens when there is a regional outage in GRS and GZRS? The data is available to be read-only if there is a failover initiated from the primary to the secondary endpoint. Whereas what happens in read-access GRS and read-access GZRS is that if there is an outage, then this failover is kind of automatic, which means that you automatically get a read access from the secondary endpoint. So Microsoft recommends these options for maximum availability and durability. However, the geo options carry a risk of data loss. Okay, so can you guess why there is a data loss risk? That's because the copy action of the data from the primary region to the secondary region is happening asynchronously. So if there is any outage in the primary region, after any write operations have been done there but have not been copied yet to the secondary region, that amount of data will be lost. But then you have to choose between maximum availability or that little bit of data loss, which according to Microsoft documentation is close to 15 minutes. The durability percentages are as follows. LRS is designed to provide 99.11 nines, ZRS 99.12 nines, GRS 99.16 nines, and read access GRS 99.16 nines of readability from primary and 99.99 read availability. The naming convention of the storage account, these are some of the rules. that it should be between 3 to 24 characters. It can contain only numbers and lowercase letters. It should be unique within Azure, and that means that no two storage accounts can have the same name. The endpoints. Each storage account has a unique global namespace. They can be accessed via HTTP and HTTP requests. So the Blob service is HTTPS account name blob.core.windows.net. The table service is similarly table.core, q.core and file.core, similarly for queues and file services. One another decision that you have to make while creating the storage account is the performance tier, whether you want a standard versus premium tier. Premium tier makes data available via high performance hardware, which is solid state drives, which are optimized for low latency and higher IOPS. The next concept is an access tier. There are three types: hot, cool and archive. This kind of option is available only on few accounts, Blob Storage, GPv2, but GPv1 do not support tiering. So what is a hot tier? The hot tier has higher storage cost than the other tiers but lowest access cost. So if you're sure that the data is highly active and you're expected to do a lot of CRUD operations on that particular data, then better to use a hot tier, which will keep your transaction costs at very less. Cool tier, on the other hand, has lower storage cost and higher access cost. So if you're sure that the data is more stored but is not accessed very frequently, then go for a cool access tier. And finally, an archive tier, which has the lowest storage cost and highest data retrieval cost. The data can take several hours to be retrieved. Examples could be long-term backup, secondary and archival data sets. So now let's see how the hierarchy of a storage account looks like. The storage account for a blob storage has got containers, which has got blobs, and there are three kinds of blobs: block blob, page blob and append blob. Table storage has got tables within it, and each table has got entities which in turn have properties. File storage account, the hierarchy is file shares, directories and files. And queue storage has got queues, and each of the queue has got different messages. Now with the understanding of the storage account itself and the other features like redundancy options, the access tiers, performance tiers, let's understand what are the different account types. Because when you're creating a storage account, you need to select a type of account, which are of 5 types: general purpose V2, V1, block blob, file and blob storage account. The characteristics of each of these are to be seen in 6 different buckets. What are the supported services for general purpose V2? It supports all of the core services as well as data lake Gen 2. It supports both standard and premium performance tiers. It supports all the 3 access tiers, and it supports all the replication options. The deployment model, however, is only resource manager, and the data is of course encrypted. If you see general purpose V1 here, now it does not support any access tiers, as well as there are reduced replication options. However, it also supports a classic deployment model. Whereas blob storage, as the name suggests, it only supports creation of blobs. It cannot support queues, files, table storage, and even in blobs, it only allows you to create block and append blobs only. The support performance tier is only premium, no access tiers, and the replication options are also LRS and ZRS only. File storage, as the name suggests, it supports only creation of files, and it supports premium tier, no access tier, LRS and ZRS kind of replication options. Blob storage, this also supports only block and append blobs, but this one supports the standard performance tier along with all the access tiers, and the replication options are LRS, GRS and RA-GRS. The kind of storage account type is going to be one of the factors relating to the Azure storage cost, the others being region, what is a redundancy option, the volume of data stored, the transactions or the API calls, and the data transfer cost or the bandwidth charges, especially for data egress, which is the data moving out of Azure. For the data moving inside Azure data ingress, the charges are 0. So these are the different things that you need to keep in mind when you are, analyzing the Azure storage cost. We'll be doing this particular demo for creating a storage account in our upcoming video. So please stay tuned, and if there is any feedback, leave it in the comment section. Thank you so much.